So then people are still holding on to the idea that it's not safe when it was safe for the time when we were living clean.
Forever, yes. And we were literally living with our animals. And so our microbiomes were very much shared. There's so much of the microbiome and genomic biome that we share with the animals we cohabitate with. We don't in our minds even have the capacity to envision that microscopically we share so much back and forth at the genomic and cellular DNA level because cells cross-communicate. This research came out of the Human Genome Project, where we figured out that, hey, wait a minute, so much of the contribution to our genome, what makes us genetically human, comes from the bacteria and the viruses that actually inhabit our bodies, not just what mom and dad give us with 23andMe, 23,000 genes, but actually there's millions of genes that come from the bacterial load that we have and the diversity of that load that's shared at the genomic DNA level, the crosstalk back and forth. And that actually, if you think about it, when I give lectures, I say, mom and dad gave you the hardware. The biome and the bacteria in your environment gave you the software. And so it's really, if you think about that, Steve Jobs' concept of cell phones, it doesn't do a lot unless you have software in it. So we may look like what mom and dad does because the hardware was given to us with 23,000 genes, but the software that drives us genomically, which actually runs our immune system, runs metabolism, does all kinds of things, is really brought about by the genomics of the bacteria and viruses and other, the microscopic organisms that live in and on us that actually crosstalk that our bodies rely upon to complete our genome. And
so you're saying all the microbes in the raw milk are actually very beneficial for us?
Extremely so, and intentionally so, manifestly structurally critical. And when you think about 1930s and 40s and really the wonderful discoveries of antibiotics and saving soldiers' lives and the wonderful passion and emotion of saving someone's life with an injection of an antibiotic, penicillin, that was a fantastic, it transcended so much pain and injury and loss of life that we celebrated killing bacteria. But it was indiscriminate and we didn't understand really what we were doing. Now, I'm not against antibiotics. I think they're a phenomenal tool, but they have to be reserved and purposely used because we abuse them, we get antibiotic-resistant bacteria. We die from that. I mean, MRSA is killing people left and right. So we have to be appreciating and understanding what makes us have a strong immune system. And literally, it's 80% or more of an immune system is the diversity of bacteria that inhabit our gut and the food that feeds it. And that is madness. If you were to say that in a 1980s or 1990s medical school, they would say, no, kill that stuff. It has no purpose. I don't know why it's there, but get rid of it. All it does is cause problems. Now we're starting to evolve a little bit and say, wait a minute, the human genome very much manifestly needs this diversity of bacteria. We need to eat whole food to feed that bacteria, keep it alive and well, so we don't need an antibiotic, right? So we can keep our immune systems functioning and not have all these really bad diseases we're getting. All these autoimmune diseases, which are actually defined by the fact that you've lost your bandwidth of your genomic data to drive your body. Your body's gone, it's gone, from normal and balanced, if it ever was, into like literally a peanut in a can, just shaking around, going crazy. It's trying to find the information and drive itself properly. And it doesn't have it. So it really, what I'm speaking about here is very much coming out of the Human Genome Project, which was in the 1990s and early 2000s, which basically said that, wait a minute, we're not alone here. We're not just one person. We are literally bacteriosapiens. And bacteriosapiens need to have a diversity of bacteria that we connect with, and they need to inhabit us. And then we need to feed them. And the food that feeds them are whole foods. They're not preserved foods. Preserved foods, what do? They kill bacteria to extend shelf life. So you need to have good foods that are whole that actually nourish the diversity of good bacteria in the gut. And by the way, the good bacteria will out-dominate immensely and mutualistically in your gut competitively to assure that you remain strong and healthy. So that diversity actually sorts itself out instead of getting these really bad, wicked bacteria that take over and make you sick. you actually have a diversity of bacteria which keep them all in check, with the pathogenic bacteria in the minority, or even if they're present at all, always kind of being suppressed by the lactobacilli and coliforms and bifidobacteria and all the wonderful bacteria. There's a whole diversity of pseudomonas and all kinds of stuff that inhabit our gut that should be there, that run the show. And so we're also missing the mucosal lining in our intestines. Have been just wickedly destroyed by antibiotics and by preservatives in our food and GMO and all the Roundup Ready stuff in the environment that we have. And that mucosal lining has made us more susceptible to pathogenic injury, which is really quite sad, because a normal, healthy human being will have a nice thick mucosal lining inside of their intestine, which is not only an inoculum of all the beneficial bacteria, but also is protective. So you don't get a pathogen going and burying itself into the tissues and causing hemolytic uremic syndrome with STEC or E. coli. And that those will go through you or be outcompeted, so it wouldn't actually have an ability to cause the hemolytic uremic syndrome attacking the actual tissues inside the intestines. So we're actually structurally affected by the fact of what we've been eating and how we've been treating ourselves for the last 50, 60 years. We actually have lost some structures, which makes us immune compromised also. So it's just a deep, broad concept. But to bring it back to our conversation, raw milk is the first food of life. It is the product of Mother Nature's blueprints operating on a generation by generation basis, with the pressures of only the good succeeds and the bad dies off. And as a result, only the optimal first food of life would actually be propagated to nourish the young at its most immune compromised time. Just came out of the birth canal, doesn't have much of mom stuff because that stops at the placental barrier. You know, the umbilical cord doesn't share the same blood, right? So you basically transfer the immune factors through colostrum in the first 2 to 3 days after birth, and all the birth canal juices, all that wonderful juice from mom's birth canal, are the first inoculums for the gut. And they're very rich in acidic bifidobacteria and all kinds of wonderful things. And then colostrum, which is packed filled with all kinds of antibodies and serum from the blood. And then that triggers the whole Pitocin response, which lactation and letdown of milk, where actually lactation begins, where you actually get raw milk in the second or third day. And that is packed filled with prebiotics, all the wonderful oligosaccharide sugars and all the kinds of things that are specialized to nourish the baby and also protect the baby. By the way, oligosaccharides are a very interesting sugar. They're not actually a nourishment to the baby. They're a nourishment to specific bacteria which protect the baby. Dr. Bruce German figured that out a few years ago. Said, what's this oligosaccharide sugar? It's not digestible by the baby, but yet it's there in plentiful amounts in raw milk. By the way, what it does is suppresses pathogens and encourages the growth of bifidobacteria, which is so important in terms of the protective ecosystem in the gut of a baby through 6 or 8 months. So much science says raw milk is a universal human food that's been around for a long time, and it will build your immune system. It does 3 things. It nourishes completely, it protects you, and it directs stuff. Direction comes from the microRNA. What do you think the pharmaceutical companies figured out about microRNA? It came from milk. Nourishing, obviously, it's got everything in there. It's got sugars and proteins and fats and everything. And it is the sole food of life for the first 3 or 4 months of a baby.
So does it matter that it came from a cow instead of from a human? So how's it going to direct a human life?
It's interesting in that I don't know that the direction actually works. I don't know that, and they're working on that now. But I do know that it's very interesting that some of the antibodies are transferable, the antibodies. The fats are a fantastic method to transfer all kinds of bioactive elements from the source of the milk to the gut, down the lower gut. What's the first thing that happens when milk is consumed? Raw milk is consumed when it hits the low pH of the 1 to 2 pH in the stomach. It curdles, it becomes cheese immediately. It becomes a coagulated big old clump, which is protective of the killing action of the acids. So that's how you transition through the stomach to get into the lower gut, where it can actually take up and participate in the microbiome in the gut.
So you're saying a lot of enzymes will not be destroyed because of this curdling effect.
Exactly. You get the curdling effect. That's how you make cheese. You add acid to milk and you acidify. You can use vinegar if you want. So it's very interesting how Mother Nature has protected the elements that are bioactive in milk to transition the upper gut, which is low pH, which is it's kind of a kill step for the body if you think about it really. Transitions through the upper gut down to the lower gut, where it has very low pH, or to be higher pH and then lower pH, and actually becomes part of the lower gut microbiome, which is the seat of the immune system. So it's really interesting, the genius of how these wonderful bioactive elements, including alkaline phosphatase, which is destroyed in pasteurization, can transition the upper gut to go to the lower gut and actually work as an anti-inflammatory compound in the immune system. And there's all kinds of other things, lactoperoxidase and lysozymes and bacteria, all kinds of bacteria. Some die, some don't, but they're protected in this clump of cheese that your body makes when it gets to the low pH in the stomach.